Tiangong, which translates to Celestial Palace, is China's modern, modular space station. It is a testament to human ingenuity, orbiting our planet at a speed of over 17,000 miles per hour. This orbiting laboratory is not a single object, but a collection of specialized modules, carefully connected in space. It serves as a home and workplace for astronauts, a platform for scientific experiments, and a bright symbol of exploration in the night sky. Many people look up and see its steady light, moving across the stars, a small but powerful reminder of our reach beyond Earth. Understanding its purpose is the first step toward appreciating its complex design. The goal of this project is to recreate this magnificent structure as a realistic three-dimensional model. This is more than just a technical exercise. It is an act of digital craftsmanship. The process will guide you through the journey of building something complex from nothing but simple shapes and data. We will transform basic cylinders and planes into a detailed and believable representation of a functioning space station. This essay will explain each step in a calm and clear manner. It is designed for anyone interested in three-dimensional art, engineering, and the wonders of space exploration. No advanced knowledge is required to begin this journey. This endeavor beautifully merges the worlds of art and science. The final result will be a detailed three-dimensional masterpiece, a digital twin of the station that soars above us. Every great creative project begins with good research. For a three-dimensional model of a real-world object like Tiangong, collecting high-quality reference images is the most critical first step. Your final model can only be as accurate as the information you gather. Begin by searching for official photographs from space agencies like the China National Space Administration and from news outlets that cover space missions. Look for images that show the station from many different angles: front, back, top, bottom, and three-quarter views. These will help you understand the overall proportions and the relationship between the different modules. Dig deeper and find close-ups, solar panel arrays, docking mechanisms, exterior handrails, antennae. Also search for material textures, metallic hull close-ups, gold and silver insulation blankets, and solar cell patterns. Create a dedicated folder and keep a well-organized reference library. Give files clear, descriptive names. For example, Tianhe module port side.jpg, not image 123.jpg. In addition to photographs, look for diagrams, illustrations, and line drawings. Simplified views clarify shapes and connections. Study modules, Tianhe, Wentian, Mengtian, and how they join to form the station's T-shape. As you collect, study, identify main components, notice harsh vacuum shadows, and observe subtle wear. This builds the mental model that will guide your hands. Once you have a comprehensive collection of reference images, the next step is to create a set of simple blueprints, guides inside your three-dimensional software, ensuring accurate proportions and scale. You do not need to be an engineer. The goal? Clean, simple line drawings for three views: front, top, and side. Use any 2D drawing software: Photoshop, GIMP, or Inkscape. These plans are your scaffolding. Look for official or fan schematics, or create them by tracing your photos, front and side, capturing modules, solar panels, and robotic arms. Do not worry about small details. Capture core shapes and relative sizes, and set a known measurement, for example, the length of the Tianhe core module. Keep drawings clean and simple, using a single thin, brightly colored line on black or transparent backgrounds. Create separate image files for each view with identical pixel size and perfect center alignment. This alignment is crucial so the reference planes match in 3D. Blueprint creation forces detailed study. Notice subtle solar array angles and where modules connect. Think of this as drawing a map before a long journey. It gives direction and confidence so you do not get lost. That knowledge is invaluable when building 3D shapes. With your blueprints ready, open your three-dimensional software. It is good practice to set units to meters and place your blueprints on front, top, and side reference planes. The first stage is blocking, using primitives to rough out the entire station. A long cylinder for Tianhe, shorter cylinders for Wentian and Mengtian, thin boxes or planes for solar arrays. Match overall size and position to your blueprints. Do not worry about details. Establish primary forms and correct proportions. Move, rotate, and scale until they align from all angles. This is the easiest time to change module lengths or solar panel angles. Step back and check from different perspectives. Does it look right? Does the scale feel correct? Making big changes later is difficult. Lock in proportions now. Once you are satisfied, you have a complete three-dimensional sketch with every piece in the right place and scale consistent. This simple collection of cylinders and boxes is the skeleton for all subsequent detail. It is a crucial step that ensures your final model will be structurally sound and accurate. Take your time here to get it right, as everything else will be built upon this framework. Section 5. The heart of the station. Modeling the core modules. Now that you have a solid blockout, begin refining the main components. Transform the simple cylinders, Tianhe, Wentian, and Mengtian, into recognizable forms by adding polygons for correct shapes and contours. Start with Tianhe, the central hub. Add edge loops, model tapered ends and distinct rings between segments. Pay attention to docking ports. Represent them with nested rings and a simplified hatch structure. Work with a clean mesh of vertices, edges, and faces. Prefer quads over triangles. Move on to Wentian, then Mengtian. Add features like airlocks and mounting points, using loop cuts for detailed shaping. Cut circular openings for windows and model raised frames. Refine planes into panel structures, thin frames and armatures, orienting panels to catch sunlight. Keep your scene organized. Name parts. Tianhe, core, hull, Wentian airlock, solar panel, left array. This discipline is vital. You will move beyond the blocky sketch. Your model now has recognizable, accurate Tiangong forms. The station feels solid and real. Fine details come later. This is a major milestone. Section 6. The devil in the details. Adding structural complexity. With the main module shaped, add mid-level structural elements that sell scale and realism. Begin with handrails used during spacewalks, simple bent cylinders duplicated along the surface, placed according to references. Next, model antennae and communication dishes. Start with primitives and refine. Also add attitude control thruster clusters, little nozzle banks on the exterior. For hull panel seams, you can model slight indentations or use textures. For high-quality hero areas, modeled seams often look more realistic. Add frames around windows and raised airlock structures. Focus on structural elements that shape the silhouette. Do not model every bolt and rivet. Keep the mesh efficient. We will add micro-detail via textures later. Before detailed textures, complete UV unwrapping. Cutting seams, and unfolding your three-dimensional model into a flat UV map. For cylinders, place a longitudinal seam and around the caps. Aim for islands with minimal stretching. Use checker tests. Keep UV lines straight where possible, and maintain uniform textile density so detail looks consistent across the station. Once unwrapped, assign base materials, metallic hulls, slightly glossy dark blue solar cells, painted whites, and emissive for small lights. Texturing brings the model to life. Paint albedo color in Substance Painter, Mari, or Photoshop. For Tiangong, whites, metallic grays, gold foil. Space is harsh. Add faint scratches, slight sunside discoloration, and small grime streaks near thrusters. Add decals, logos, national flags, and technical labels, projected for sharp realism. Build a material stack, albedo for color, roughness for shiny versus matte, metallic for raw metal versus non-metal, normal for fine detail like panel lines, rivets, and grills. For solar arrays, create a photovoltaic cell grid with dark blue albedo and a reflective yet slightly rough surface. constantly check textures on the 3D model. What works in 2D may shift on curved forms, dance between 2D and 3D until every surface contributes to realism. Lighting in space is both simple and complex. One dominant light, the sun, but with sharp contrast and almost black shadows. Use a single powerful directional light with parallel rays and a slightly cool white color. Add a very faint fill, a large area or low-intensity dome, to lift shadows just enough to reveal detail, like faint earth or moon bounce. Use an HDRI star field for beautiful reflections. Tiny, sharp points across shiny surfaces. Place a distant Earth as backdrop. It grounds the scene and adds a soft blue ambient rim. Adjust the sun angle. Side lighting emphasizes form and texture. Backlighting creates a dramatic rim. Render at high resolution, 4K recommended, and render in passes for control, direct light, reflections, and emissive glows. Assemble passes in a compositor like After Effects, Nuke, or Fusion for precise final look. Increase small running light glows, subtly enhance metallic reflections, and add a slight bloom to the brightest hotspots. Apply a gentle vignette and a slightly cool grade to evoke the cold of space. A fine layer of film grain can unify the image. Less is almost always more. From references to color grade, this project illustrates the synergy between art and engineering. Accuracy provides believability while light, texture, and color bring it to life. For students and aspiring creators, start small, perhaps one module. Join communities to share work and get feedback. It is a marathon, not a sprint. Each step, from the first blueprint to the final render, is a learning opportunity. Keep learning, keep building, and you will find that in digital creation, not even the sky is the limit. Now, go create something amazing.